I didn't realize this.
No, it's not a pep rally. It's more like just make sure you eat it. Yeah, I didn't know that it's
I thought it was like a thing that they like filled socks with flour and then threw it at each other.
We're talking about powder puff here, guys. And I had it growing up in New Jersey, so it's not just a South thing. One of our students' sisters got in a fight. All good stuff. All right, let's take antiderivatives. This is Unit 6, a reminder. And in Unit 6, we learned that when you're taking an antiderivative and it's a composition, if it's just x, we could take the antiderivative of the outside and then multiply by the reciprocal. How do I know this? Like, I always can think about and check answers in my brain thinking about the derivative. If I took the derivative of this, it'd be cos 5x times 5. The 5 and the 1/5 would cancel, gives me cos 5x, which is what I want, okay? Take a derivative of an antiderivative, you're back to where you started. It's how I can just remember and check that the antiderivative of e to the 4x is 1/4 e to the 4x. Because if I took this derivative, e to the power is the outside, 4x is the inside. The derivative is e to the 4x times 4. The 4 and the 1/4, boom, go away, e to the 4x. So we're always thinking about this. We're always thinking about the antiderivative. We're always thinking about checking by taking a derivative. Here we have to remember that the antiderivative of 1 over x, or the antiderivative of x to the negative first, is the natural log function, natural log absolute x. Helpful thing is to always rewrite it as negative first power and try to use the power rule. Doesn't work. X to the 0 times 1 over 0. Doesn't work. That's not something. Like, is it 1? Is it undefined? No, there is some function whose derivative is this. And the function is log, it's the antiderivative of the outside, times a negative 1/6. Now, how can I check this? Take the derivative of this. 1 over 5 minus 6x times negative 6, the negative 6 and the negative 1/6, boom, cancel. Okay? These are the same. Antiderivative of the outside. Okay, well, I have a 1/5 from this. And then undo the inside. The inside, the derivative is going to be 4, so I need a 1/4. If you understand this, you can do a lot of the U-substitution ones we're about to do in your brain. You can just get the answer. If you understand, like, and you can check this, like, is this derivative going to be this? Okay, well, the 5 comes down, 4x minus 3 to the 4th, and then I have another 4 because the derivative of the inside is a 4. So the 5 and the 4 combined to get 20. That's why the 1/20th is going to go away, and I just have 4x minus 3 to the 4th. Keep that in your brain. I'd write this as 5x minus 6 to the negative third. I'd take the antiderivative of the outside. It's a negative second times negative 1/2. I have the 5x minus 6, and I also have a 1/5, giving me a 1 negative 1 over 10 times 5x minus 6 squared. Double check that, or double check this. Like, the negative 2 comes down, that goes away. Turns into a negative 3. The derivative of this is 5. The 5 and the 1/5 go away. Okay? Always mentally check antiderivatives. Fun one here. Rewrite this as 3. 8 minus 7x to the negative 1/2. Antiderivative of the outside. Positive 1/2. I need a 2. I already have a 3. I need a negative 1/7 to undo the inside. Give me a negative 6/7, 8 minus 7x square rooted, or to the 1/2 plus c. Does this work out? Okay, the 1/2 comes down. This turns into a 3, a negative 3. 8 minus 7x to the negative 1/2. Okay, that brings it down. And then I have a negative 7 that comes out. The negatives will cancel, the 7s will cancel. I just leave the 3. It works. Okay? Now, we learned this process, this undoing of the chain rule. Don't assume that just because you see some sort of parentheses or some sort of chain that you need to use U-substitution. You will have a test question that will try to trick you on this. You actually distribute, you simplify, you square. I'd rewrite this as x squared plus x to the 3 halves. There should be a dx here. I would rewrite this as x to the 4th plus 2x squared plus 1. I think you have a test question that's like exactly this. This, I would divide both of these by x. I'd split this in 2 different fractions that have a common denominator. X squared over x is just x. 3x over x is just 3. Isn't this going to be a lot easier to do? And then we just use the power rule for all of these. Okay. Now, what if it's not that simple? You got stuff like this. Some of you will be able to figure this out. Some of you will be able to see the inside, its derivative, a form of it is right here. Some of you can think, okay, this is like a chain's derivative. And if I wanted to go backwards, you may be able to figure out, it's like, okay, well, I need a 4th power. And I'm going to need that stuff that started on the inside. And then you think about the chain rule, and you think, okay, if I took the derivative of this, I'd have a 4, x to the 4th plus 2 cubed. And then I have the derivative of this would have a 4x cubed. Well, I only want an 8x cubed. If I have this 4 and then another 4, I'd have 16x cubed. So what do I need? I probably need a half here. This is how you can figure it out. Okay, let's see. The 4 would come down. That'd be a 2. X to the 4th plus 2 cubed times the derivative of the inside. 4x cubed. The 4 and the 2. Boom, 8. I think this is my answer. I'm going to go here. Okay. Now, let's say you're like, nah, Mr. Messner. I can't figure this out. This is where the process comes into play. The U-substitution process. It's very formulaic. There's a lot of steps involved. But if you're not getting this and seeing this and understanding why this is our answer to this, got to use this process. And here's the process. Step 1, set U equal to the inside of the composition. Step 2, take the derivative of both sides, making it look a little bit different. It's called a partial derivative. You'll say du instead of du dx. You'll say du equals 4x cubed dx. You'll solve for dx. I'll have 1 over 4x cubed du equals dx. This is all work to be done to the side. This is sometimes confusing to students because you're taking a derivative, even though they're asking you to take an antiderivative. This is what you got to do. Now, we substitute. What we start with and what we ended with, we will substitute back in. So that goes in here. This goes in there. What this process does, it's getting us this 1/2. It's going to get us the values that we need eventually. Okay? So I get integral 8x cubed u cubed times 1 over 4x cubed du. Stuff will cancel. The x cubes cancel. The 8 divided by the 4 cancels to be a 2. Okay, watch. So I got 2u to the 4th plus c. 2u cubed plus c. Everything else stays the same. Okay, not plus c, sorry. 2u cubed du. I was already taking the antiderivative in my head and getting the answer. The key step to this is not forgetting to take the antiderivative. This step is all to simplify so we get something that I can take the antiderivative of. When I take the antiderivative of u cubed, just treat it like x cubed. It's nothing fancy. It's nothing special. It's a power rule. Add 1 to the power, multiply by the reciprocal. Multiply that by the 2. That becomes a 1/2. We replace u. Boom. We get what I was looking for. Formulaic, step-by-step way to get something that maybe you can figure out intuitively. Let's see. I realize this is some sort of like derivative that comes from a chain. I'm going to try to do this by just thinking. I get this stuff in the inside. I know it's got to stay in the inside. Okay, that's like the whole chain. I got a 5 here. I'm just going to start with like that. Now, if I took the derivative, I'd get a 5. And then this would turn to the 4th. And then when I take the derivative of this, I'd get a negative 3x squared. So I have a 5 and a negative 3, which is negative 15. I don't want a negative 15x squared. I just want 1x squared, which is why I'm thinking I need a negative 1/15 here. And I think this is my answer. If you can get this, great. Shows you really understand the chain rule. Shows you know, like, okay, I'm taking the derivative of the outside. The 5's going to come down. We're going to take the derivative of the inside. I'm going to get a negative 3. A 5 and a negative 3, boom, 15. It's negative, boom, that's what I want. And I have an x squared, so this is what I'm going to get. Let's say you can't. U equals, inside of your composition, take the derivative of both sides, make it look a little fancy. Solve, negative 1 over 3x squared du equals dx. Substitute. Integral x squared, this becomes u. This becomes 1 over negative 3x squared du. Okay, again, I substitute it in u, and I substitute 4 dx. If stuff is right in the world, I'm just left with u's. This is an indication that U-substitution works, is if you can get rid of x's. If you can't, then you know that you made a mistake in your U-substitution. I get this. Easier to look at, easier to take the antiderivative of. I do that. I get u to the 5th times 1/5. The 1/5 and the negative 1/3 combine to give me negative 1/15. I replace 1 minus x cubed back in. Boom. I got what I was expecting. All right. There should be a parenthesis there. I'm going to try to get the answer myself. If you could figure this out, great. I get sine. Now, there will be questions where you're required to use U-substitution. These are not those questions, if you figure this out. I know I'm going to have sine x squared. The derivative of sine is cosine. But when I take the derivative of x squared, I get 2x. I want 3x. Okay, so 2 times what number equals 3? Well, 3 halves. I'm thinking I need a 3 halves there because the 2 times the 2x times 3 halves is going to give me 3x. So I'm thinking this is going to be my answer. Let's see if we can get that using U-substitution. Step 1, set u equal to the inside of the composition. Du equals 2x dx. Solve for dx. Substitute. Boom. There's that 3 halves. Antiderive 3 halves cos u. It's just the antiderivative. 3 halves cos x. It's just going to be 3 halves sine x. Or 3 halves sine u. We replace what u is equal to. Boom. See if I can get this one. I know I got a negative cosine. That's the antiderivative of the outside. That'll give me a positive sign. When I take the derivative of the inside, I'm just going to have a negative 6x squared. Okay, well, that negative is going to take care of that negative and give me a positive. But I don't want a 6x squared. I want just an x squared. So I'm thinking I need to keep this as negative 1/6. So cosine positive sine. Ooh, hold on. I got to think about this. Cosine's derivative. Okay. negative cosine, positive sine. So this will be a positive 1/6. And then I'll take the derivative. I think this needs to be a positive. See, like this is why it's sometimes tricky. It's sometimes tricky to do this stuff in your brain. When I take the derivative of cosine, I'll get negative sine. I'll have the negative 1/6. And then this is going to be negative 6 x squared, which will turn it into a positive. I think this is it. Let's see. U equals 4 minus 2x cubed. Du equals negative 6x dx, negative 6x squared dx. Negative 1 over 6x squared du equals dx. And I got x squared sine u, negative 1 over 6x squared du. The x squareds cancel. And I get negative 1/6 sine u. Okay, the antiderivative of sine is negative cosine. Negative sine's derivative is going to be positive cosine, so I was right. Positive 1/6 cosine u is the when you take the antiderivative, the du goes away. When you take the antiderivative, it's like I took the antiderivative of this with respect to u. It's gone. And boom. All right, these e to powers, I know it's going to be an e to the x cubed. I'll have a 3x squared. I don't want a 3, so I'm just going to have a 1/3. This is the u step-by-step process to get that. Since we don't have like that much time to like review, and honestly, since this isn't that big of a deal of a lesson, it's like important to maybe try to figure it out yourself rather than memorize this very long, intricate process. I used to like, live by this process. But I don't know, techniques and processes are things that people forget. Understanding like one thing is something I can remember. Understanding the chain rule, something I can keep my head around, and then understand how to undo it. X squareds cancel. The antiderivative of e to the u is just e to the u. I keep doing this. Take the antiderivative. Here's me taking the antiderivative. I get 1/3 e to the u plus c. The antiderivative of e to the u is just e to the u. You don't have to do anything crazy. It's not a power rule. It's just like the antiderivative of e to the x is e to the x. And I get that. This one's going to be tricky because I'm feeling like I do have e to the 3 over x. But then I have to like think about taking the derivative of 3 over x. The derivative of 3 over x is negative 3 over x squared. I don't want a negative 3, so I'm thinking I need a negative 1/3 here. Honestly, that's what I think it's going to be. If you could figure this out, maybe you could save yourself a lot of time and a lot of stress on your quiz and on your test. Let's see, u equals 3 over x dx. The derivative is like literally what I just did, like what I was doing, this process. It's negative 3 over x squared du. I keep messing this up. This is du and this is dx. Okay, I'm going to multiply by x squared, divide by negative 3. So I have x squared over negative 3 du equals dx. So I got e to u over x squared times x squared over negative 3 du. Again, I took u, substituted in here. I took x squared over negative 3 du, and I substituted in there. The x squareds cancel. There's that 1/3. Take the antiderivative of negative 1/3 e to the u, and I get negative 1/3 e to the u plus c. Replace negative 1/3 e to the 3. Boom. Get this as your answer. Okay. Now we want to find the area. Okay. I need everybody to do this 2 different ways. I need everybody to get the answer, but with u's and with x's, because there are specific questions that require you to understand the whole change of your base, which means change of your boundaries. And I'll show you what it is in a second. first let me see if I can get this antiderivative. I know it's going to be some sort of cubed, because the derivative of the cubed, 3 stuff squared, and then the derivative of the inside is 3x squared. I just have x squared, so I need 2 3's to go away. I believe it's going to be 1/9. Okay, because like the 3 and then another 3, but I just want x squared. The x squared will come from the derivative of the inside. Okay, so this is my antiderivative. And I believe I could plug in 0 and 2 in this and get my answer. 1/9, I'm not going to do all the math. 9 cubed minus 1/9, 1 cubed. 980, I don't know what 9 cubed is. You know what 9 cubed is, anybody? I don't know what it is. Yeah, it's a big number, so let's just leave it like this. Okay? But let's get this answer a different way using U-substitution and changing our bases, changing our boundaries. What do I mean by that? When I do this process, and this is something required for you to know how to do, when I do this process, I change dx, which stands for, a width of a rectangle. This is an infinite sum of heights times widths, y's times x's. Like, that's what we're doing. And the x's are on the x-axis. When I do this process of U-substituting, I all of a sudden change it from an x-axis to a u-axis. And now these widths are u's. 0 and 2 are x's on an x-axis. If I change to a u-axis, I need u's. Now, here is the connection between u's and x's that you've established. And if x is 0 or x is 2, you can find what u is equal to. Plug in 0 for x, you get u is 1. Plug in 2 for x, you get 2 cubed plus 1, you get 9. That's where this 9 comes from. That's where this 1 comes from. To be correct, you would change your boundaries, change your bases. You're changing your bases from dx to du. You change your boundaries from x's to u's. Okay? Now, going through the rest of the process, we would have 1 to 9, 1/3 u squared. You would take this antiderivative, you'd get u cubed times 1/9. Okay, u cubed times 1/9. That's what I got. From 1 to 9, however, hold on, but this is 0 to 2. But watch. This from 1 to 9 gives you the very, very same answer as this does from 0 to 2. Because it's just like, when do you plug in and what do you plug in? So we need to make sure we're comfortable doing both. There will be specific questions that we will do later in the homework that require us to be able to do this change of bases. Okay. All right, let's see if we can get the answer right away. I know it's e to the x squared. The derivative is e to the x squared times 2x, and I want 2x, I just want 1x, so I need a 1/2. If you got this, great. You're skipping some stuff, but you're ready to change bases when asked. I think the answer is going to be 1/2 e to the 9th minus 1/2 e to the 4th. I'll check this answer with my calculator at the end. Because it's very important. We talked about this in class. This means take an antiderivative. You can't plug this into a calculator. Your calculator doesn't know how to antiderive. But why is this notation the same as this? Because this means accumulate. Your calculator can accumulate. It can do a very, very intensive Riemann sum to get the approximation of this. But what do you have to do? What Newton discovered, you have to take an antiderivative. It's the whole Area under f prime, change in f. Area under velocity, change in position. Fundamental theorem of calculus. So we are taking antiderivatives to find the accumulation of this. Velocities times times, change in positions. Same thing. One's the antiderivative of the other. All right. U equals x squared. Du equals 2x dx. Dx equals 1 over 2x to u. Integral x e to the u 1 over 2x du. The x's cancel. I will correctly change my bases from x's to u's. If x is 2, u is 4. If x is 3, u is 9. This is 4 to 9, 1 half e to the u. When I take the antiderivative, I get, I'll just write it over here. One half e to the u, nothing changes, plus c, but from 4 to 9, it's the same as 1 half e to x squared from 2 to 3. You get 1 half e to 9 minus 1 half e to 4. Oof. All right. If I take the antiderivative of the outside, it's going to be a 4/3. Add 1 to 1/3. I just get x on the outside. Now, I'm going to have a 4/3, and I'm going to have a 2, but I just want 1. This is an 8/3. I need a 3/8. This is like doing what we've done before. 4/3 comes down. I get a 1 half. The 2 comes down. This is going to be right. If you figure this out, hooray. You can skip a lot of stuff. Oh, I forgot to check. I don't know if I have that much time to do all this, but might as well. Math 9, 2, 2, 3, x e to the x e to the x squared dx is going to be a big number, but I believe that's 1/9 e to the 9th minus 1/4 e to the 4th. Uh-oh. Whoops. It's 1 half. I don't know why I was typing that. There! See? Look at us. Who would have thought? Not me. So the answer to this was 3/8, 7 to the 4/3. Fantastic. No. 8 to the 4/3, which we could calculate. Cubed root of 8 to the 4th. Yeah, I don't want to do that. Minus 3/8, 7 to the 4ths. 7 to the 4/3. Great. Let's get that. Using U-substitution, changing our boundaries. 1 over 2x du equals dx. We got integral x. I'm going to write it as u to 1/3. This is 1 over 2x du. The x's cancel. I'm going to take the antiderivative of this, but after I change my boundaries, if x is 0, u is 7. If x is 1, u is 8. There's that 7 to 8, 7 and 8. So I'm going to antiderive 1 half u to the 1/3 from 7 to 8. I get u to the 4/3 times 3/4 times the 1 half plus c from 7 to 8. So that's 3/8 u to the 4/3 plus c. You won't need to worry about it from 7 to 8. And you get the same thing. Okay? Ooh. I can check that if I want to. I got it right. Confident in this stuff. All right. This is x squared plus 9 to the negative 1/2. If I took the antiderivative of that, I'd get x squared plus 9 to the positive 1/2. I'm going to stop right there. If the 1/2 came down, I'd have a 1/2. And then the 2x's derivative would be a 2. The 1/2 and the 2 would cancel. I believe I would just have x. The derivative of this would be 1/2 x squared plus 9 to the negative 1/2 times 2x. I think this is right. And I think we're going to be good from 0 to 4. I think my answer is going to be 4 squared, which is 16 plus 9, which is 25. The square root of 25 minus the square root of 9. This I will plug in and check because this is just 5 minus 3. I think my answer is just 2. What? This is just 2? This is just alpha F1. This is just 2? Any live updates about the game? Any Snapchats? No? Nothing? Two! Oh, great. 2. All right, well, let's get that a different way. So they're having fun. It's a nice day. U equals x squared plus 9, du equals 2x dx. dx is 1 over 2x du. All right, so change my boundaries. If x is 0, u is 9. If x is 4, u is 25. It's just like, when do you plug in 0 and 4? Do you want to plug it in later or plug it in earlier? I mean, that's the idea. So this is x root u and then 1 over 2x du. The x's cancel. This is 9 to 25 of 1/2 times, I'm going to go ahead and rewrite it so that it's a negative power. So I can use the power rule. It's a negative 1/2. I add 1 multiplied by the reciprocal. Adding 1 becomes u to the positive half. Multiplied by the reciprocal, that's a 2. The 2 and the 1/2 go away. This turns into u to the 1/2 plus c from 9 to 25. You can go back to x's if you wanted to, if this is the process you choose to use. If you choose to figure it out, you probably have a very good understanding of the chain rule, and good for you. It's going to be quicker doing it that way. Everybody needs to know how to change bases. And there'll be specific problems where changing bases is like required that we'll be doing later. Like right here. And then, okay, we got this. I can do this. Now, what we find is sometimes there's hidden compositions. Here is a hidden composition. This is when we're asked to take the antiderivative of f prime over f. Now, if I asked you what is the derivative of log of f, you'd have an outside and an inside. The outside's a log, the inside is the f. You'd have 1 over times f prime. Remember, the derivative of log is 1 over. So that means the antiderivative of this is actually log f. Okay? Derivative on the top, function on the bottom. The derivative, bottom. If you notice this, what's going on is that there's a hidden composition of a first power in the denominator. We know that the antiderivative of x to the negative first is log absolute. Okay. The quick way to do this is just to realize your answer's got to be log x squared plus 1 somehow. Think about taking this derivative. You'd have 1 over x squared plus 1 times the derivative of the inside, which is 2x. That's what I have. This is my answer. From 1 to 2, I'd get log absolute 5 minus log absolute 2. I'm done. One thing I could do, and this is important. I don't think we've seen this much. There's a log property that says if you're subtracting, it's like exponent rules, it's the same as dividing the two things. You may see this as an answer choice. I don't think I see it much on the AP exam, the AB exam, having to simplify. But log 5 minus log 2 is the same as log 5 over 2. Okay? This is an easier answer to look at. Double checking my work, always nice to do and get your answer and feel good about it. Though you guys are checking your work with me, though I make mistakes all the time. You get this, and you get the same thing. Okay? So, U-Substitution Method. How do we get that same answer, log 5/2? U equals the entire denominator. That's the inside of the composition. Du equals 2x dx. Dx equals 1 over 2x du. Integral. 2x over u, 1 over 2x du. The 2x's cancel. Change my bases from 1 to 2 to 2 to 5. Since both of the 2x's cancel, it's just 2 to 5 of 1 over u du. The antiderivative of that is log absolute u plus c from 2 to 5 is the exact same thing as log x squared plus 1 from 1 to 2. Okay? This guy. I see the top is like a form of the derivative of the bottom. I'm going to start by like understanding that that's like a first power brought up as a negative first power. The antiderivative is going to be a log. I'm thinking my answer is log absolute 3 minus 4x cubed, but I got to double check. I'd have 1 over 3 minus 4x cubed, cool, but then this would be times negative 12x squared. I only have 5x squared. So I need to turn negative 12x squared into 5x squared. What do I need? I need like a 5/12, a negative 5/12. And this is me just kind of like figuring it out. This is a method to do this, is to the figure out method, to understand like the derivative of the inside is going to be negative 12x squared. I don't want that. I need 5. So I need to get rid of the negative 12 and leave 5. So that's why I need a negative 5/12. Let's see if that works. And this is from 1 to 2. And I'll have to write that a little bit smaller. I'll figure out what that equals later. So u equals the bottom. Du equals negative 12x squared dx. This is where the 5/12 is going to come from. Dx is 1 over negative 12x squared du. Substitute in. I got 5x squared over u, 1 over negative 12x squared du. X squareds go away. If I have an x of 1, u turns into negative 1. If I have an x of 2, 3 minus 32, 8 times 4 is 32. 3 minus 32 is negative 29. Great. Okay. I'd rewrite this as negative 5/12 times 1 over u du, the antiderivative of which is negative 5/12 log absolute u plus c from -1 to -29. I think my answer is negative 5/12 log, the absolute of -29 is positive 29, minus negative 5/12, the natural log of 1. -1 absolute is positive 1. Now this is just 0 that's important. So I think my answer somehow is this. Now I'm feeling like I made a mistake with the question and that you cannot find this because it might be over an asymptote, but let's see. Okay. 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 All right. All right. Enough of showing the change of the bases. I'm just going to get this answer really quickly. I think it's log 4 minus x squared. If I took the derivative of this, it'd be 1 over 4 minus x squared times negative 2x. I don't have a negative 2x. I just have an x. I need to get rid of the negative 2x that I get from this derivative. I need a negative 1/2. From negative 1 to 1 is negative 1/2 log 3 minus negative 1/2 log 3, which is negative 1/2 log 3 plus 1/2 log 3, which I think is 0. Ah! Look at that. Cool. Oh, watch what's going to happen, guys. I think I know what's going to happen. When I plug in negative 1, oh, this is, you know what? This is why U-substitution sometimes is so great. If you plug in negative 1, 4 minus negative 1 squared. What's 4 minus negative 1 squared? 3. Plug in 1, what do you get? 4 minus 1 squared. 3. What do you get if you have an integral from 3 to 3? 0. Oh, isn't that sweet? Changing bases is awesome. Thanks for paying attention for those 2 seconds, guys. I appreciate it. You don't have to do anything past 3 to 3. I don't need to do that. Sweet. All right. Here's where changing bases and like antiderivatives are not going to help you. You are asked to just rewrite this integral into f of u du. This is where you have to use U-substitution. You go through the process of setting u, taking the derivative, solving for dx, substituting in and changing your bases. 3f of u, 1 over 5 du equals 6. This is not 1 to 2. This is 5 to 10. But I don't want anything besides f of u du in it. So what I'm going to have to do is take this 3 and this 1/5, pull it out as 3/5, multiply both sides by 5/3 to get rid of it, giving me, and I'm going to write smaller for the other one, 5 to 10 f of u du equals 10. 6 divided by 3 times 5. Okay? So it's not just setting U and saying, oh, this is going to be 1 to 4. No, it's more than that. You got to figure out what the constant is. You got to pull it out, et cetera, et cetera. Later. So I will change my bases to be 1 to 4. I will keep the 3x. I will turn this into f of u. This turns into 1 over 2x du. That equals 6. The x's will cancel, but I'll be able to pull out the 3 halves and then multiply both sides by 2/3. Later. And I get, thank you, 1 to 4 f of u du equals 4, 12/3. And the last problems we do as well very much are not a figure it out, but a just do the process, and it's actually more helpful. So let's do the next two. Change my bases, change my boundaries. 2 minus 1 is 1. 2 minus 4 is negative 2. Might freak you out, but that's what it is. I don't like changing boundaries when it goes from left to right to left. But we'll find is like sometimes that means our answers are going to be negative. X's cancel. This is a negative 2. I'll divide by negative 2, giving me 1 to negative 2 of f of u du equals negative 3. There's nothing we can do with this. Like, take the antiderivative, you get big F. I have no information about big F. They just wanted me to show I know how to change my bases. Okay, so like this is where we wanted to end. There are AP questions that require you to understand how to get here. Okay, and here too. You could figure out what the antiderivative is. Like you could say, okay, big F of x to the fourth. But when I took the derivative of big F, I get regular F. Take the derivative of x to the fourth, I get 4x cubed. I don't want 4x cubed. I just want 1x cubed. I need a 1/4. Good. Great. It's not what they're really asking you to do. But this is the antiderivative of the inside. So, we go through the process. We change our bases. We substitute. We keep a new integral. It stays 0 to 1 because it's x to the fourth. Pull out the 1/4. Multiply by 4. Done. Oh. Final questions. These are like table problems. These are like U-substitution table problems. We hope we don't have to find the area. Turns out we don't. These are kind of like the problems you had a little bit on your quiz today, where you're going to use the values of F. Your goal, understanding that this is F, and then you're asked to find the accumulation of F prime. You know that it's equal to the change in its antiderivative. If you found this antiderivative, you can use U-substitution to do it. You can just find the change in it. I think the antiderivative is f of 2x, but I think about it. Okay, chain rule, f of 2x times 2. I don't have a 2, so I need a 1/2 here. Find the change in this from -2 to 2. If you don't understand how to get that, you use U-substitution. U is 2x, du equals 2dx. 1/2 du equals dx. This is -4 to 4 of f prime of u times 1/2 du. The antiderivative is 1/2 f of u plus c. Don't need it, from -4 to 4. Or what I got originally was the 1/2 f of 2x plus c from -2 to 2. Either way, you're going to get the same answer, right? Because it's like plugging in 4, plugging in 2. You get 1/2 f of 4 minus 1/2 f of -4. This is f. F of 4 is -1. That's like the y coordinate. So I have -1/2 minus f of -4, 1, 2, 3, 4, is 0. So my answer is -1/2. Did not give you much space for these. My apologies. You could go straight to the antiderivative. For this one, I would. It's really easy. Like the antiderivative of this says, got to be f of -2x plus 1. Understanding the derivative of this is going to be -2, I need a -1/2 from 1 to 3. That's -1/2. F of -6 plus 1 is -5 minus -1/2 f of -2 plus 1 is -1. F of -5 is -2, so I have -1/2. Again, this is f, this is f, so I'm looking at the y coordinates. Very important. It's like sometimes we look at slopes, y coordinates, areas. That's calculus. Plus 1/2 f of -1, f of -1. Oh, jerks. I go down 1 over 1, 2, 3. So if you go down 1 over 3, that's like going down a third over 1. So I need to go down a third, down a third. I'm at 1 1/3. That's 4/3. You need to be able to do that. So my answer is +1 plus 4/6, which is 2/3. I have 5/3 as my answer. Did not give you much space for this. Maybe you use U-substitution for this one. I mean, I know what the antiderivative is. It's got to be f of x squared. Okay, but it's got to be something else. If I took the derivative of this, it'd be f prime of x squared times 2x. I don't want 2x, I just want x, which is why I need a 1/2. The last one I did without using U-substitution. So this one I will use U-substitution. Say, I don't know the antiderivative. I still haven't figured it out, Mr. Messner. Okay, let's go through it. U equals x squared. Du equals 2x dx. Dx is 1 over 2x du. Change my bases. It's 1 to 4. X f prime of u, 1 over 2x du. X's cancel. 1/2 f of u is the antiderivative plus c. Find the change between 1 and 4 because I've changed my bases. The c goes away, turns into 1/2 f of 4 minus 1/2 f of 1. F of 4 is -1, so this is -1/2. F of 1 is 0, so this is also -1/2. The last two good ones, you could use U-substitution to get this. I don't think it's required if you understand the derivative of the log. Be 1 over f times f prime. You want me to show you how to get that using U-substitution? Fine. The composition is not seen. The composition is the bottom to the first power. So you set u equal to the bottom, du is equal to f prime, dx. What happens is that those f primes are going to cancel with each other. 1 over f prime du equals dx. Now, what's interesting is this becomes f of negative 3 and this becomes f of 3. Okay? Like I'm plugging in x. I could find what those values are if I wanted to. F of negative 3 is 2. F of 3 is 0. I don't know if this will work. I don't think this works. I'll show you why. This becomes 1 over u. I guess it's f prime over u. Times 1 over f prime du. The f primes cancel. You take the antiderivative, it's log absolute u from 2 to 0. What's wrong, Mr. Messer? You said this doesn't work. You're not allowed to take the natural log of 0. That can't be done. So, if you could take this answer, this is what you get. And you won't have a question like that on your quiz. And if you do, whatever. I'll give you a heads up about it. And it's my mistake. Let's make sure that f of 3, 1, 2, 3 is 0. That's a problem. F of negative 3 is 2. I probably should have changed it to be like f of 2. All right, I changed the question. That's a 2. That's a 2. F of 2 is 1. That's a 1. That's a 1. That's a 1. This is a negative log 2. All right. Same goes for this. It's easy enough to realize that the antiderivative of this is just e to the f. Take the derivative, it'd be e to the f times f prime. That's what I get. From negative 2 to 2, I'm just going to do this. Call it a day. E to the f of 2 minus e to the f of negative 2. F of 2 is 1. E to the first minus f of negative 2. Negative 1, negative 2. Oh. Down a third over 1. So that's 1 2/3. So it's like, if this is 6/3, this would be 5/3, 4/3, 3/3. So 5/3. Peace!